So we have learned the HTTP protection, right? We were learning that. So HTTP protection was first root guard we have learned. Then we have learned the loop guard, right? How it's happening, right? Then we have learned loop guard. Then we have a third type of protection we are calling as a BPDU guard and BPDU filter. So those technology used for the same purpose actually. Give me a moment. Okay, so we are going to learn the BPDU guard and filter. So if Rahul, you are not in last class, so you are missing a lot of things. But how it is working actually, we have a couple of switches, right? So Anurag, I will ask the question because you are on the last class. So this switches was connected. So we learn about the first root guard. Root means whatever root. For example, this was the root was elected, right? So some attacker was coming here and they are making like lowest bridge ID and MAC address, right? And then it is saying like I'm a root. After that, here was DP port, and once DP port receiving the uh, lowest root bridge ID kind of things. Then it was putting this port, this switch itself in root inconsistent state, right? Because it's saying you are unauthorized because we are running as a root guard features. Okay, so it was dropping the packet, right? And putting that interface into root inconsistent state to protecting our or here also DB for example. So protecting our the root. Then we learn the loop guard, right? Loop guard was there. It, for example, this was blocked, right? Something due to bug or software or some failure, right? So this port become a forwarding. For example, it's receiving the BPDU, and this is RP, right? Simple, okay? It's RP and receiving the BPDU packets. And then what happened? Like it's stopped receiving the packet. Then what this blocking port will think like something went wrong and we need to convert our topology. So after 20 seconds, because BPDU guard is BPDU uh, uh, message stored on the interface for the 20 seconds, right? After 20 seconds, what will happen? It will start sending the BPDU by saying like I'm a root kind of. So it will say like I have superior BPDU, so whatever I'm receiving, you can become a root port. It will become a root port. It will become a DP port. So there is no blocking port at all, right? So all in forwarding state. So loop got. So we have learned how we can protect our root port and DP port kind of things. So now the question is how we are going to protect our end user connector. For example, some Parrot software or something is running in here, Parrot or something. Okay, and it's installed like OS kind of things, and it's start manipulating our root switches. It's connected on access port, but it's start manipulating that. Okay, DTP we can disable it because DTP like we can switch port mode access, right? I have shown you like it DTP got disabled in DTP lecture, right? And apart from that, like if you made the access list, however, also you can make this system itself as a root switch or something. So as soon as what I need, if this system or any Parrot software running system or malware system or any hackers inside the building only is trying to make its system itself as a root switch, right? In that case, if we have connected on access port itself, so it should not entertain that BPDU message for the access port as well. So we have a technology or protection like a BPDU guard and filter. What is the difference is in that? Like as soon as if you will enable the BPDU guard here, right? As soon as it will receive the packet, it will what it will do? It will drop the packet and put that port into error disable state. Okay. But in filter, what it will do and generate the log. It will not put that port into error disable state, but it will drop the packet and generate the log, SNMP log we are calling. Okay. So these are the different means it will put into error disable. This will not put into error disable. But in any case, packet will be dropped. So we were protecting root port, be protected DP port, be protected our access port. Now our all the topology, spanning tree topology got fixed, right? Cool. So BPDU guard, BPDU filter is there. And one more technology you can learn here kind of. You understood, right? I will show you lab as well. So UDLD, one more technology we are calling as a UDLD. Uh, UDLD, unidirectional link detection. Someone saying loop detection, right? So you have done that, but you have seen in a loop section, loop guard. So for example, this one you have seen, right? This you have seen this one. So this one I made the topology like it was stop generating the BPDU packet, right? So it was creating the loop because none of the port was in forwarding. This was going, this one like that. It's created the loop, and multiple MAC address was learning with different port. Okay, same MAC address on different port kind of. So loop was created. It's broadcast storm happened on the network, right? So UDLD, what it will do, this kind of failure, right? Loop guard failure was like, you know, software failure, you can say. Software failure, right? But UDLD, what it will do, it will check kind of hardware. I mean, cable. We have some fiber cable, right? Rahul know very much about this because he's working in OE. So we have a couple. We have a transmit and we have receiving kind of things, right? So what UDLD will check, for example, here we have a switches, right? What it will check, if any direction of the traffic, for example, transmit or receive, means bidirectional, unidirectional link detection. Traffic should be bidirectional, should be going this side, coming this side, and should be bidirectional, not unidirectional, as is happened for BPDU here, right? Last time we have done that. So should be bidirectional. If it's Cisco proprietary, for example, it will work on the Cisco devices only. So in case any unidirectional link detected, for example, transmit is happening but receiving is not happening, right? In that case, UDLD generally packet will drop, but you will not identify, right? Why is it dropping? Because one connection is happening, is sending TCP packet, and three-way handshake is not able to perform. In that case, what will happen? Like your transmission session will be not established. I mean, TCP session will be not established. I mean, so in that case, it's very hard to, your PC cannot communicate, but it's very harder for you to identify the issue where it is, right? So in that case, you can enable the UDLD. So as soon as you will enable the UDLD, then if any detection, any unidirectional detection is failing, then it will detect and generate the log. So we have a two cases, two mode of the UDLD. First is a normal mode we are calling, normal, and second we are calling as aggressive mode. Okay, aggressive mode. In aggressive mode, what will happen? It will put that port into error disable. This will simply drop the packet. Aggressive means it's also increase the hello timer by 1 second, I guess. I'm not pretty much sure about this number, but I think. And normal mode, it was like 15-second kind of hello packet was. So it will aggressively checking, but it's generally if you have hardware resource will be utilization will be high in aggressive mode, and normal mode will be less, because every time every second packet will not be forwarded. These are the three packets was protection was left. So this UDLD, I don't know, I can prove by lab or not, but this BPDU filter and BPDU guard, we will prove that. Okay. So let's stop the recording, and if you guys have any question, we can discuss this more.